Okay, graphing a cosine function number 6. So we're asked here to find the amplitude, the period, the phase shift, and then to graph the function. The amplitude is easy, isn't it? It's just the absolute value of this. So the amplitude is equal to 3. The period, we know the period of a sinusoidal function is 2 pi over omega. In this case, 2 pi. Remember, let me clue you in on this. That A, we're using this form here, A cosine omega minus alpha. Billy calls it fish, but omega here. So we know that this value, this omega value, is 2, don't we? So 2 pi over 2. So the period is just pi, isn't it? Now we need the phase shift. And the phase shift is opposite omega over, opposite alpha over omega. Alpha is pi, isn't it? It's opposite. And omega was 2. So our phase shift is pi halves. Usually what I do is this. I'll take this whole piece out just so I can see where exactly one interval falls. I'll take this piece out and I'll put it between the domain of one cycle of cosine. So I'll take 2x plus pi less than or equal to 2 pi greater than or equal to 0, and I'll solve for this x value right here, and that's what I'm doing. Solve for this x value right here. So I'll get negative pi. I'm just going to add pi to everything. Is less than or equal to 2x, which is less than or equal to 3 pi, right? Then you're going to have to divide everything by 2. Divide by 2. Divide by 2. Whoops. I should have subtracted that, so I should have pi here, right? Pi halves here, right? And then we'll get x is greater than or equal to negative pi halves, less than or equal to pi halves. And if you look, we had a period of pi, didn't we? And the distance between negative pi halves and pi halves is exactly. So I'm going to start to graph this thing out now. So I've gotten all the pieces I'm supposed to get. Phase shift, period, amplitude. So I'm going to go ahead and start to graph this thing. I'm just going to graph one cycle of it. So here is there is no k value, so I'm going to say this is line is y is equal to 0. Y is equal to 0 is my horizontal line of symmetry here. Then I'm going to start graphing this and just say this thing has this general shape, doesn't it? This is general shape that looks something like this. It's going to go like this. Head back up. Now I am aware that this is a periodic function and it's going to keep doing this. But all I'm looking at is the piece that's in solid right now. So we know that the amplitude, I'm going to go check out the amplitude. We know that the amplitude was 3. So this is a height of positive 3 here and negative 3 down here for our amplitude, right? And then this point right here is the point negative pi halves. This is exactly why I did this. So what I'm going to use right now is this piece right here. This thing comes in really handy. I'm going to use this piece right here. This is my left boundary. This is my right boundary. Now, it's not the only way you can do this, but it's the way I chose to do this one. So this is negative pi halves. I'm looking for a point, and it's a maximum, so it's 3, isn't it? Here. And then this is the right bound, which is over here, which is pi halves. It's also a maximum, so it's 3 here. And I think because it's a cosine curve, all I'm going to look for is this piece right here. And it's the middle of those two, isn't it? So I'm going to use midpoint theorem. And I'm going to take negative 1. Actually, I'm going to take, right? Midpoint is x sub 1 plus x sub 2 divided by 2. So pi halves plus negative pi halves over 2 is equal to 0 over 2, which is equal to 0. So this is the point 0, what? Negative 3. Exactly, isn't it? So that's a good enough curve for me. All those pieces put in place. All right? So hopefully this is making sense to you. If not, please make comments, or if it does make sense, tell me that it makes sense. If you haven't already subscribed, please subscribe. Thanks.